Okay, welcome to video 4. This is where we start with the AP style questions. So let's start here. Number 18. The function f is given by this big function here. Which of the following describes the function f? So looking at here, it says this is all domain. All domain. So let's go ahead and factor the denominator here. So we'll get x minus 8 times x plus 3 all over. What two numbers multiply to be negative 24 but add up to be 5? That's going to be x plus 8 times x minus 3. Okay, so we should have excluded values at x can't equal negative 8 or positive 3. So we should have negative 3 is not the excluded value. Negative 8 is the excluded value. And positive 3 and a horizontal asymptote at 1. That's true because these are both degree 2. Yeah. So it's got to be, hold on, let's check out this right. So negative 8 and positive 3. That's right, negative 8, positive 3. So it can't be this one because this is negative 3. So it can't be C, can't be A. And this one says the function does not have a horizontal asymptote, but it does. They're both degree 2. If they're both degree 2, it's leading coefficient over leading coefficient, which is 1. So it can't be that. So it must be B. Okay, 19. The function f is given by this function here and has a line of y equals 3 as a horizontal asymptote. Which of the following must be true? So if it has y equals 3 as a horizontal asymptote, that tells us, because that is not 0, so that means that the degree on top, the degree of the numerator, is equal to the degree of the denominator. So right now the degree on top is 3 and 3, good, so a can't be x. And since it's 3, that means the leading coefficient over leading coefficient. So the leading coefficient of the top is a. The leading coefficient of the bottom is 2. And we know that this must equal 3. So we just multiply both sides by 2, and we should get a is equal to 6. So looking over here, f of a is equal to 6. Nope, that's not right. A is equal to 6. That might be right. The limit as x approaches infinity is equal to a. That is not right because the limit should, since it's an asymptote, that should be 3. Should be 6. Nope. Same thing. Should be 3. None of the above. So it's got to be B. Okay. Next up, which of the following is equivalent to the limits as we approach this? Okay, so the degree on top is, so this is in behavior. That's a negative infinity. So the degree on top is 2. The degree on bottom is 4. So since the degree on bottom is bigger, that means y equals 0. So the limit should be 0. D. And then the function f is given by this big function here, which describes the end behavior of f. So the degree on top is 3 over the degree on bottom, which is 2. So that tells us that there is no horizontal asymptote. So if that's the case, we need to figure out what the horizontal, or what is the behavior of this as it goes. So this is a negative. So since it's leading up with a negative, that's going to flip the graph upside down. A 3 on top usually goes like that. So as we approach, as x approaches negative infinity, it should be flipped, so that should be going to positive infinity. And as x goes to infinity, instead of going up, it'll be going down to negative infinity. So it should be, as we go negative, so not that one. As we go negative, we go positive. That's good. As I go positive, I go positive. Nope, because that one's not true. As we go negative, negative. Nope. Negative, positive. Yep. And then positive, negative. Yeah. So it should be D. That was kind of a short video. Let's keep going. The function f is given by that function there. Which of the following describes the function f? So let's see what they're talking about. X-intercepts here. So we want to know when is the function 0, but it can't be a whole. So let's see here. We have, if I want to factor this out, this is 4 minus x. Let's rewrite that. We're going to factor out a negative, and we'll make that negative x minus 4. That way it looks like our x minuses, and we can see factors that might cancel out. So on bottom, I'll have a negative x minus 4. On top, what two numbers multiply to be 24, but add to be 2? That's going to be a positive 6 and a negative 4. And then we can see those two cancel out. So there will be a whole. There'll be a whole at positive 4, and x-intercept at, I don't know what the y value is yet, an x-intercept at negative 6. Let's see if we can save ourselves some work and not have to look at the y value. So let's see here. X-intercept at negative 6. All these say negative 6. So vertical asymptote at 4. Nope. A whole at 4. That's promising. Vertical asymptote at negative 4. And a whole at negative 4. No. Nope. So it should be B. We have an x-intercept at negative 6 and a whole at positive 4. Okay. Use the following table here. Which of the following must be true for 15 and 16? Use this table. Which of the following must be true for function f? So, the graph has a maximum at x equals negative 3. So if we're looking at this, this is positive. So here, what should be happening is I'm positive here, and then as I get to negative 3, there is an x-intercept, and then I am negative again. This intersection right here looks like what's happening here is that's undefined, and they're both negative. So this is probably a whole. So it's more than likely a whole, but it could also be a vertical asymptote if they are both approaching down. So if this could be a vertical asymptote that has a multiplicity of 2. And then so here there should be a this is a defined x-intercept, and so we're going negative to positive. So if that's the x-axis, this is going negative to positive right here. So let's see. The graph of f has a maximum at negative 3. Nope, definitely not a maximum. Minimum, nope, definitely not a maximum. So there's definitely not extrema. That's no extrema there at all. F has exactly 2 distinct real zeros. That is true, because this is from negative infinity to positive infinity. This is the only removed value, so this one might work. So those two are out. f has exactly 3. Nope, definitely does not have exactly 3. The graph of f has a vertical asymptote at x equals 0. It could be a vertical asymptote, but it could also be a hole. So it's not that one. It's not must. So this must be true. So C must be true. There are two distinct zeros. Which of the following could be scroll up here. Which of the following could be an expression for f of x? Well, if I know I have an x-intercept here, that means that on top I must have x plus 3, since there is a hole at, not a hole, an x-intercept at -3. So that would work there. And then there's also an x-intercept at 2, so I should also have an x minus 2 in here. Something else I must have, this is an excluded value, so I must have an x on bottom. And there may or may not be an x on top, because if there's an x on top, that would be a hole. So that would create a hole. But then x squared on bottom, there's no squared on bottom. This would have to be a multiplicity of 2. So this would have to be it. Undefined and a hole. So let's see what this is. I mean, that matches ours exactly, so maybe that one. That one wouldn't work because the x-intercept's in the wrong spot. This one wouldn't work because those would be excluded values. Those would be excluded values, so it would have to be A. It would have to be A. Okay, one more sheet and then we are done. Last 3 questions. The function f is given by this function here. Which of the following describes the function f? So it's asking for holes, so that means that we're going to have to factor it. This is difference of squares, so that's x plus 3 times x minus 3. And then the bottom here, what two numbers multiply to be positive 15 but add to be 8? So that is going to be x plus 5 times x plus 3. So we should have a hole at -3. So D. Okay. The figure shows the graph function f, which of the following could be expressions for f of x. So let's see here. We have an x-intercept at -2, so on top I must have x plus 2. There is a hole at 4, so I should have x minus 4 on top and x minus 4 on bottom. That way they cancel out and create a hole. And other than that, that's all I can think about. So let's see. So x plus 2 over x minus 4, good. Oh, nope, not A, because I need x minus 4 on bottom. So it's going to be one of these two. This one looks good, this one does not. So it's got to be C. And last, the figure shows the graph of function f. Which of the following must be true? So the limit as we approach 4 from the positive is infinity. Nope, that's not right. F of 2 equals 0. So let's see here. F of 2 is not 0. Definitely not 0 there. So it's not that one, not that one. The limit as we approach 4 is equal to 3 times f of 0. F of 0 is 2. So 3 times 2, which would be 6. That one is weirdly written, but maybe. F of -2. So f of -2 is 0. Plus f of 0, which is 2, is equal to 0, and that's definitely not true. So it must be C. So yeah, f of 0 is 2, so those multiply there. And that completes that worksheet. So quiz on Tuesday, guys. Email me with any questions.